We handled 1 million requests per hour on a single server, not a serverless function, not a Kubernetes cluster, not 100 microservices. Just one server, one database, one Redis instance, and here's the craziest part. It cost us $15 a month. Let me show you exactly how we did it because this changed everything about how we think about scale. 6 months ago, our API was barely handling 10,000 requests per hour. We were running a standard Node Express API connected to Postgres, pretty typical setup. But we were making some terrible mistakes. Every single request, new DB connection. Every query, synchronous blocking call. No caching, no optimization, no thought about scale. When traffic spiked to 20,000 requests per hour, the server just died. CPU hit 100%, memory maxed out, response times went from 200 milliseconds to 5 seconds. Our on call engineer got paged at 3 am. That was me, not fun. We had two options, throw money at the problem with many servers or actually fix the architecture. We chose the hard way and it paid off. First mistake, DB connections. Every request was calling database.connect, creating a brand new connection, using it, then closing it. This is expensive. A DB connection takes 50 to 100 milliseconds just to establish itself. But if you are getting 1,000 requests per minute, you are spending minutes just opening and closing connection. The fix, connection pooling. Instead of creating new connections, we created a pool of 20 connections that stay open. Simple change, massive impact. We went from 10,000 to 100,000 requests per hour just by reusing connections. The code change was literally 5 lines. I'll show you the exact code in a minute. Second mistake, blocking IO. Our code looked like this: data equals database.query. Seems innocent, right? Wrong. That equal sign, that's blocking. The entire thread sits there waiting, doing nothing while the DB thinks. If a query takes 50 milliseconds, that thread is frozen for 50 seconds. With 100 concurrent requests, you need 100 threads, each one burning memory, context switching constantly, CPU crying for help. The fix, async await. Now while waiting for the DB, the thread can handle other requests. One thread can handle hundreds of concurrent requests instead of just one. We went from 1000k to 5000k requests per hour. Same hardware, just better use of resources. Final optimization, caching with Redis. Here's the thing, 80% of our requests were asking for the same data. User profiles, product catalog, configuration data. But every single request was hitting Postgres. So we added a Redis in front of the database. Before querying Postgres, check Redis. If it's there, return it, done. If it's not there, query Postgres. Then save it to Redis for next time. With a 5-minute ETL, our cache hit rate was 80%. That means 80% of requests never touched the database. Database load dropped by 80%. We went from 500k to 1 million requests per hour. So let's recap the numbers. Before our optimizations, 10,000 requests per hour, 2.5 second response time, $500 per month in server cost. After 1 million requests per hour, 45 millisecond response time, $50 per month. 3 optimizations: connection pooling, async IO, and caching. In the next video, I'll walk through the actual code for each optimization. Stay tuned for more production war issues. Thank you.